So let us go from this to a slightly broken solution, okay? Where, as I basically suggested in the beginning, we could have used while instead of if. Sorry. So the only change is that if count equals to one will be changed to while count equals to one in both the producer and the consumer. Let us look at what would happen if we have multiple consumers and a single producer. Again, can this lead to issues? So basically, almost same system where you have one producer, two consumers. You start again from one consumer. The second consumer and the producer are both in the ready state, while one consumer is running. Count is equal to zero, so you cannot do anything. So you wait on a conditional variable. And you sleep, and now the second consumer gets to run. Okay, I mean just gets scheduled, so it now is running. It checks if count is equal to zero, and yes it is, so it goes to sleep. So now both of the consumers are sleeping, so the operating system can only schedule the producer. The producer gets scheduled. It basically acquires the lock. it it checks if count is one, and it is not one, so it would basically put one at put the value into the uh, into the buffer, and then count changes to one, basically using the put method. It signals the sleeping threads to wake up, okay, but only one of them wakes up. We have basically said that signal wakes up one thread, while broadcast wakes up two threads, right? Or all sleeping threads. So basically, it wakes up one thread, the other is sleeping, and it's ready. Now it basically releases the uh, conditional variable. It releases the lock, and now it 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 gets basically back, since round robin has the larger quota or something. So it continues running, tries to acquire the lock. Is count is count equal to one now? Yes, it is. So it goes to sleep, and now it's sleeping. So now you have two threads that are sleeping, and you have the first consumer again running, and the first consumer runs. It gets the value. It wakes up. It sends a signal, right? But the signal wakes up the wrong thread, basically. Instead of, as we said, that the difference between signal and broadcast is that signal would wake up only one thread, broadcast will wake up all threads. So now signal basically woke up uh, the wrong thread. It woke up the second consumer. Okay, now the second consumer gets to run. Uh, well, once the first consumer basically finishes, the second it sleeps. The second consumer gets to run, and well, is count equal to zero? Yes, it is equal to zero, because the first consumer already consumed that data. So now it goes to sleep, and you have everyone sleeping now, right? So this this is an example of when basically you have again the scheduler messing up your system. Broadcast, if you have sent broadcast, it might have solved that problem, but you might have still run into issues. So you basically, in reality, what you do is that you require multiple conditional variables, and you, in that case, you will have two of them. One is empty, one is full or fill, okay, and you basically these two conditional variables will be signaled in at different stages, right? So if it's empty, you basically signal that it's empty. If it's full, you signal that it's full, instead of having a single conditional variable running for both of them, empty and full. So in that case, you will basically have the producer will use the conditional will wait on the conditional variable empty, while the consumer, okay, will wait on the conditional variable full. Okay, and this was today's lecture. I will work on recording the next lecture as soon as possible so that you guys can basically get up to speed with your assignment 3. Again, I'm really sorry for the past couple of weeks. I have been extremely sick, although it was not appearing, but yeah. So thank you and see you on Thursday.